Okay, so let's say we want to do the integral of x plus 1 over x dx. And you'll notice that we have, in this we have, excuse me, a monomial denominator. Which means we can split this up, right? We can write it as x over x plus 1 over x. Right? The same as if you had like 7 over 4. You could write that as 3 plus 4 over 4 or 2 plus 5 over 4 and then split up the fraction. So we can split this up. So I can write this as the integral of x over x dx plus the integral of 1 over x dx. And each of these are easy to do, right? Wow, we can actually put them back together even, right? And we know what the integral of 1 is. And we know what the integral of 1 over x is, which is ln x. Well, ln absolute value of x. Yeah. Caught me, I was just in the process. And what do we need? Onion plus c, right? Plus some constant. Now, let's contrast or compare this with the integral of x over x plus 1. So now, we do not have a monomial in the denominator, right? The denominator is binomial. So, binomial denominator. So we could think of, well, what could we do? What did we do yesterday? Use substitution. So what are we going to substitute for? Yeah, x plus 1, right? Because if we do that, then we can get a monomial in the denominator, right? Which means, okay, we could do that. So we could do something with a monomial denominator. We can always split it up and then integrate each individual term. It's a little bit tougher here, right? We can't split this up. Okay, it's like writing 7 over 8 or something, right? You can't split that up. So we're going to have to let u equal x plus 1. So what does that make du equal to? 1 dx, right? Or just dx. And if u is x plus 1, then what's x equal to? U minus 1. Because we've got that here, right? We can't have x's in here, right? It's got to be simplified. So this becomes u minus 1 over u du. We say, hey, well, that looks like the one we just did, right? Well, it's got a minus sign instead of a plus sign, but it's the same idea, right? So let's do this just slightly differently. So let's bring the u up top, but do it as a u to the negative 1, right? Now we can just multiply by u to the negative 1. So that gives me 1 minus 1 over u du. Whoops. And now we can take the integral, which is but we weren't doing u's, were we? We're doing x's. So now we're going to go back and substitute in. And we said, oh, well, u is x plus 1, right? So that's going to be x plus 1 minus the ln of the absolute value of x plus 1 plus c. Now here's the thing, c is some constant, right? So adding 1 to it, adding some other constant to that, so we don't need the plus 1, right? I mean, so we're just going to get rid of it. We'll roll it in to the c. Okay. It's just some arbitrary constant. So now it's an arbitrary constant which is one bigger than it was. It's still just an arbitrary constant. So it becomes x minus the ln of the absolute value of x plus 1 plus c. Okay, and of course you can verify that by doing what? Taking the derivative. Okay. So, what else? Well, what if we have a monomial radicand? Monomial radicand. Radical? What's radic? Well, I mean, that's pretty easy, right? Because we can just multiply that through, right? It's just an x to the half. So multiply it through, we'll get x to the 3/2 minus x to the 1/2 dx. Well, we can do that, right? We can find each of those individual integrals, right? So 3/2 becomes 5/2, so it's 2/5. X to the 5/2, right? We didn't have to substitute anything here, right? We can just work this one out. Minus 2/3 x to the 3/2 plus some arbitrary constant. Okay. And we can just leave it like that. That's done. As compared to what if we have a binomial radicand? Okay, so I can't just multiply an x into a root x minus 1, right? We can't do that. So we want to make the radicand a monomial, right? So what are we going to do? Well, we're going to say let x minus 1 equal, or let u equal. So we're going to start with let u equal x minus 1. If we do that, then this becomes a monomial radicand, and we just did one with the monomial radicand, right? So we're just going to do kind of the same thing. But as soon as we say let u equal, then we got to say, well, what's du? Dx, right? It's just 1 dx. And what's x? Because we got an x here, right? So we got it. X is u plus 1. So this becomes the integral of, so we've got u plus 1, that's the x. We've got square root of u, and the dx, that's just the same as du. So we've got du, which looks a lot like what we just did, right? So one's got a minus sign, and one's got a plus sign. So we can multiply through. So this will be u to the 3/2 plus u to the 1/2 du, which will become, what was it? It's 2/5 u to the 5/2 plus, oh wait, that's a half. Plus, 2/3 u to the 3/2 plus c. Now, so we're going to have to replace the u. So what we want to do actually here, before we just go and say u is x minus 1, is we're going to want to simplify this expression, right? So what we're going to do is we're going to factor stuff out. So our lowest power of u is u to the 3/2. We also have a common factor of 2 in the denominator, right? So we can pull out a 2 u to the 3/2. That will leave me with a u to get u to the 5/2, a 5 on the bottom, right? So u over 5, plus, well, that's just a 1. We got everything we need there, so we've got a 1/3 plus c. And plus c at the end, right? Okay. Yeah, not that one. See, the 1/3 isn't just a 1/3, right? It actually is being multiplied by u, which isn't really u, it's really x, whatever, is u. X minus 1. We're not quite there yet because we're going to simplify this. Okay, so go 2. All right, so common denominator is 15, right? You need 3 of these then, so 3u plus 5. So we're going to pull the 15 out of here and stick it over here, right? There's a 15 on the bottom. So we've got 2 15ths, u to the 3 halves, 3u plus 5 plus c. Okay, now we've got this as simple as we can. Now we're going to replace the u, right? So we're going to substitute back in, what was it? X minus 1. So x minus 1 to the 3 halves, 3 times x minus 1 plus 5 plus c. And this will simplify, right? So I'm running out of space, so we'll just do the final line. Oh, lots more space. So 2 over 15, x minus 1 to the 3 halves, 3x minus 3 plus 5, plus 2, plus c. Okay, so 2 over 15, x minus 1 to the 3 halves, 3x plus 2 plus c. Fun, huh? Where's that? Somewhere I have the key. All right, let's do another couple. So it's basically the idea, right, is if we have an expression with a binomial denominator, we want to replace that binomial with a monomial, and we can handle that. If we have a binomial radicand, we want to replace that with a monomial radicand, and we can handle that. So, example 1. The integral of 2x over x plus 1 quantity squared dx. Okay, so we look at that and we say, all right, I have a binomial denominator. I want to replace that with a monomial. So what's u going to be? X plus 1. So du is? Yeah, dx. And x is? U minus 1. All right, so we got everything we need to do the substitution now, right? We're going to replace the x up top with the u minus 1. Now, while we're doing that, let's throw the 2 out front, right? Save ourselves a little grief. If 2 is a constant, that can go out front. So let's go 2 times the integral of, okay, what do we got up top? We got x, but x is u minus 1. What do we got on the bottom? U squared. What's dx? dx is du. All right, so now it's all in terms of du. Okay. So what do we do now? Well, we say, all right, let's do this. Let's go u minus 1 times u to the negative 2 du. Right? So we have 2 choices, right? We could split it out. You could write it as the integral of u over u squared minus the integral of 1 over u squared with the du in there, right? But I think it's easier to say, let's just pull that off. Then we've just got it as a sum or a difference, and we could do the integral of that with appropriate equal signs, I'm sure. So it's 2. Okay, so u times u to the negative 2 is u to the negative 1. Well, okay, let's just write that as 1 over u, right? Because we look at 1 over u, then it's a lot easier to do the integral, right? It's, I know what that is. Minus u to the negative 2, which we'll just kind of leave as a u to the negative 2, because I think that's a bit. And then du. Oh, no, we don't need the integral anymore, right? So what's the integral of 1 over u? Ln u. Ln absolute value, right? So when we say ln u, this is what we mean, right? We mean the ln of the absolute value of u. Then what do? We got to increase this by 1, so it becomes -1, and we got to divide by -1, so it becomes plus 1 over u plus c. Now, it doesn't matter if I write the plus c in the brackets or out of the brackets, right? Because 2 times c is still just c's, right? So it's just some arbitrary constant. We can't simplify this, and there's nothing. So all we do is we go back and we replace the u with x plus 1, and let's multiply by 2 at the same time. So it's 2 ln absolute value of x plus 1 plus 2 over x plus 1 plus c. Okay, and again, for any of these, if you take their derivatives, you're going to get back to the original expression, right? Which on a test you shouldn't do until the end, especially on a more complicated. If it's a simple one, yeah, quickly. But if it's more complicated, yeah, I wouldn't rush to do it. Okay, one more, and then I have all the answers for these, and I'll stick them up on the board. You can look at them. They take up. Wait a sec. Let's So again, this has a binomial radicand, 3x minus 2. So that's what u is going to be, right? We want to get a monomial radicand. So u is equal to 3x minus 2. What's du equal to? 3 dx. What's dx equal to? 1/3 du, right? Because we're going to have to replace this, right, with the 1/3 du. And what's x equal to? So x is equal to u plus 2 over 3, right? So we're looking at this and say, well, okay, I can't have an x sitting in here. Now, actually, there is one of the questions that you'll do where it's better to leave it as an x for a little while and then replace it with u than it is to just immediately replace with u. And the thing that tells you that is experience. So you just have to gain some experience, right? You have to do enough of these such that you look at, oh yeah, okay, I did one like that, and it was a mess when I didn't. And actually, what we've done here, this would be a mess if you just went in here and just stuck in the x plus 1s, right? Like you'd still get down to this, but it would take forever. Okay, so the lesson that I learned was when I'm doing this is, you know what, you really want to do this. You really want to factor it out and get this all simplified to the point where, yeah, okay, that's totally done. And then we'll substitute at the end as opposed to jumping in here and saying, wow, let's throw in the x plus 1. Because now what you're taking out is, instead of just a plain old u, you got a factor of x plus 1 to the 3/2 that you're taking out, right? And so don't do that, right? Not a good idea. I'll show you my first attempt at one of them, which it's just a mess, right? And it still gets down to the right answer, but okay. So what do we got? We got a u plus 2 over 3. We got a root of u, or I don't know. Let me just call that u to the half, and we got a 1/3 du. So let's take out the thirds. Right? So we got 2 3s on the bottom. Let's go with 1/9. Right? That makes this a lot simpler, right? Because now it's just one line. Okay. I don't have any, and they're just constants anyway. So. Okay. So 1/9 integral u to the what? Three over 2 plus 2 u to the 1/2 du. All right. Well, that's easy to integrate, right? That's a good point. So 1/9. All right, what do we do? Increase by 1, 5/2. Multiplied by the reciprocal, 2/5. So put a bracket down because it's 1/9 times. Okay, so we've got 2/5 u to the 5/2. Okay, what else? Increase by 1, 3/2, multiply by, which will give us. There you go. Right, and then just for fun, I'll throw the c outside of the brackets this time, right? Doesn't matter, again, right? It's just some arbitrary constant. So, you know, if we end up with numbers that we got to add to it, now just remember, the numbers that we're adding to it need to be just a plain number. It can't be something that's being multiplied by an expression with a variable in it. Okay, so like back in the beginning one that we did where you just had that -1 sitting there and then the plus c, or plus 1, it's like, okay, roll that into the c. Okay, factor, right? So what can we take out? We can take a 2. So now I got 2/9. Okay, so the 2 is coming out of here and here. These guys are 5 and 3, whatever. And a u to the 3/2, right? The lower power of u. Okay, so what do we got? We got 1/5. Well, let's just write it as u over 5. Right? So that gives me 2 u to the 5/2 over 45. It always was 45, right? Okay, plus 2, that's it, thirds. Plus 2/3. Okay, so remember the 9's are really not part of this. We got the 4 and we got the u to the 3/2. We got 3. All right, so let's add these together. So 2/9 u to the 3/2. Common denominator, 15. Plus c, what's this? 3u. Plus 10. Okay, let's pull the 15 out, right? It's on the bottom, don't want it. 15 times 9 is 150 minus 15, so that'd be 135. So 2 over 135 u to the 3/2. You can do it one step. I don't care how you do it. You do it. You get the same. Do it your way and get the same answer, and then we'd be happy.
Do it your way. Get a 16 common denominator.
What do you got? 3x minus 2 is u, right? Okay, so now we're substituting in u. I mean for u. For u, I'm substituting back in the x expression. So 2 over 135, we're not going to touch this, right? The 3x minus 2 to the 3/2. We'll do this in one swell poop, right? So we got what 9x minus 6 plus 4, or 9 plus 10, 9x plus 4, plus c. Right. And you know, if there were another common factor in here, if they're both even or something, then I'd pull another 2 out or something like that, or you know, 3, whatever. There it is. So that's it. U substitution part 2. So you got about an hour. You should spend about an hour of that hour doing these, right? Like you really just gotta pound through. You know, once you've done a few,